Hello, students. Today we are going to move on to absolute value functions, which is 3.4 and 3.5. The absolute value function is y equals a absolute value of x minus h plus k. This is your formula for the absolute value function. The vertex is going to be represented by h and k, and the a term is going to represent your slope. But let's talk about it. The absolute value function must contain an absolute value expression. So if we look at number one, where it says y equals 3x plus 2, it's not an absolute value function because it doesn't have the absolute value symbol. And in fact, if I look at this, I should be able to tell it looks like y equals mx plus b. This is actually a linear function. Let's look at number two. Would it be an absolute value function? Well, yes, because it has the absolute value symbol. So this is an absolute value function. Let's look at number three. Is it an absolute value function? Yes, because it has the absolute value symbol. So this is an absolute value function. If I look at number four, I do not see an absolute value sign, which means it is not an absolute value function. If we have the chart as we did in class and we look, we will be able to tell because there is a 2 here. It is actually a quadratic function, but that's something that we learn a little bit later on. All right, so as we said, for the absolute value function, it must have an absolute value sign. So the parent function is going to be y equals the absolute value of x. The absolute value graph looks like a V. It has to have that V shape. That's how we can tell visually that it is absolute value. When I look at that V shape, I am going to notice that there is a vertex. The vertex is the highest or lowest point on the absolute value graph. It is where it changes direction, right there. That is the vertex of the absolute value function. The vertex is located here at -3, -2. The domain of this function is going to be all real numbers because it's every x value on the left, going forever in that direction, every x value, and it's going to be every x value on the right. So your domain is all real numbers. -infinity to +infinity, all real numbers is going to count. The range is going to change, however, because the range, oh, that was your domain. Sorry, let me review. Your domain refers to your x values, and in this case, it's all real numbers unless specified. The range, see that little tail on the G? It goes with the y. The range refers to your y values, and it's going to be based on the y-axis. So if I look, my lowest y value is going to be right here, and the function is going above. There's nothing below that line on the y. Therefore, your range is every y value that is greater than or equal to -2. The axis of symmetry is going to be the line that divides the function into two equal parts. If we think about the word symmetry, we are symmetrical persons. It cuts something in half evenly. So the axis of symmetry is going to divide this in half, straight up and down. It's at vertical line, and it must go through the vertex. That's the axis of symmetry. The axis of symmetry is a vertical line, and so it's going to be x equals that number, and the number that it's going through is -3. The slope I'm going to use like I did before, but for the slope, I must look on the right side of the axis of symmetry of the green line. And so my slope is going to be up one, right one, up one, right one, up one, right one. My slope is 1/1. The y-intercept is where we cross the y-axis. So if I look on the y-axis, it's going to be right here at +1. So my y-intercept is going to be at 0, +1. The x-intercept, I'm going to look along the x-axis. So I'm looking right along here for the x-intercept. It's wherever it crosses the x-axis. So my x-intercept is going to be at -5, 0, and here at -1, 0. I'm going to look, do I have a maximum or minimum? Well, if I look at this V, there is a low point down here. Remember, that vertex is going to tell us that. It's not high in the air, it's down below. So there's going to be a minimum here, and the minimum is going to be at y equals -2. That is the lowest part of this function. If you have a highlighter, I'm going to recommend that you use a highlighter. I'm going to come here. I want to put my axis of symmetry back in here. Let me put it back in green. My axis of symmetry is in green. And I'm going to talk about where this thing is increasing. Now, this is going to be increasing. If you look at a V, we work from left to right. So it goes down and then it goes up. It's going to be increasing here on the right side. And so it's increasing where your x is greater than -3. It's increasing on the right side of this function here, that blue. My function is going to be decreasing. Let me give it a red over here on the left side. Because again, when we draw a V, we are going to draw a V like this, going down and then going up, right? Decreasing and then increasing. So it's going to be decreasing on the left here, where x is less than -3. So, I mean, it has to be one or the other because that vertex is going to be our turning point. This is going to be positive. Let's get another color for positive. It's going to be positive anywhere above the y-axis here, right? Because that's where y is greater than 0. This is why your y is positive. Your y is positive on the top. And so it's going to be, it's pinkish, it's going to be positive where x is less than -5, and where x is greater than -1. That's where it's going to be positive. It's going to be negative. I'm going to get yellow for negative because I don't see the vertex anymore. It's going to be negative where y is negative, and that's everywhere down below the y-axis, right? So after 0, we come down and we have -1, -2 on the y. So this is where y is going to be negative. As such, it's going to be negative between -5 and -1, where x is between -5 and -1, and the alligator always chomps to the right. So right here on the graph, that's where it is negative. So I understand that this is a lot going on, a lot of parts of the graph, and understanding the concepts. That's okay. I want you now to pause, and you're going to use this to try all of those down below. You're going to just try to answer all of those similar things down below. All right, now that you are back, we should have that the vertex is located right there at x equals 3 and y equals 2. So your vertex is at 3, 2. The domain of this is all real numbers unless specified. The range, your highest y value is here at 2, and we see that the function is going downwards. It's everything below. So your range should be y is less than or equal to positive 2. The axis of symmetry that goes through the vertex is going to be x equals the number because it's a vertical line, and it's 1, 2, 3. X is equal to 3. The slope, if I look on the right side, would tell me to go down 1 and right 2. And so my slope is going to be negative 1/2. The y-intercept on the y-axis, I can't tell for sure, but it's between 0 and 1. So it would be about right here. Let's go with 0.6. So I'm going to go with 0 and 0.6. And I am estimating that one. For the x-intercept, I am going to look along the x-axis, which is here, and boom, there it is, and boom, there it is. My x, oh no, sorry, that's another point. I'm going to look along the x-axis, which is down there, and boom, there it is, and boom, there it is, kind of out there. And so my x-intercept is going to be here at negative 1, 0, and out here on the green at 6, 7, 0. If I look here, this point is the highest on the graph. Everything is going to go below it. So the point is at the highest level. That's going to be, it's a maximum. And the maximum is at y equals 2. That horizontal line right there, that's my maximum. This is going to be increasing over here on the left. So it's increasing, going up, where x is less than 3. And then it's going to turn directions and decrease. So it's decreasing on the right, where x is greater than 3. Notice that these two are going to be opposite of each other. If it's increasing on the left where x is less than, but it must decrease on the right. All right. It's going to be positive above the x-axis, all of the different color. It's going to be positive all of this part up here. And so it's going to be positive between negative 1 and 7. It's where your x is between it and your alligator chomp to the right. It's going to be negative everywhere below that. And so it's going to be negative where your x is less than negative 1 and where your x is greater than 7. Oh, and we've got it all. The domain is all real numbers, and the range is y is less than or equal to negative 2. All right, so these are your parts and areas of your absolute value function. Stay tuned for the next lesson where we actually graph them.